Well, no, it's a USB-C.
All right.
What they're on. Good. Looks great. Looks wonderful. Super. We're going to teach the guys this today.
And Scott.
We're supposed to have Joe and a CBD employee over here too.
Huh. Well, I'm going to learn something.
Let me get the. I hope you do. I know, right? I hope you do learn something. This is the second iteration. I've made this presentation before in the past. So I took that one and rebooted it, revamped it. I can't do more. But it's going to be good. I don't know where Scott is. Is he looking for the blanket guy?
Who knows?
We
can
went
just-
that way. He didn't. Wish I had one.
Protest, I'll go out there and yell.
Yeah. Anyway. I want Scott to come back.
I'll check on him.
Up. There he is. Scotty! I need you in here so it's less awkward.
It's calling people off the street.
They don't want to come.
It's just right here.
That's okay. I think we should shift the time we creating events.
1 o'clock maybe, and 4 o'clock.
Well, I wasn't sure if it should be like 1 to 4 or like an 11 to 3, like an 11
Right. Yeah.
2, 4.
Might be worth trying that.
Yeah. Like I was wearing a hoodie, so I got to. Hello.
Hello, come on in. Hello. Oh, no worries. We're used to it.
It's the vibe.
It's the whole vibe. Cannabis people just get here when
We get here when we get here.
when we're present enough. After we've made our consumptions.
Yes. Welcome. We were just about to get started.
Pizza.
That too.
All right. Thank you for coming, everybody. I am Mary Allender. I'm with Medicaid OH. I'm the editor-in-chief. We've been doing this education series since September of last year here at this event space once a month. You can earn a free certificate to add to your cannabis arsenal when you're out there trying to get a job or if you just want to learn for fun. So we've been doing that. We've got events for the rest of the year, so keep an eye out for those. And a little bit about me, my background, the reason why I'm teaching this and not somebody else. I've taught in Cleveland School of Cannabis. I've taught the cannabis courses at Hawken College. I have my Master of Science from the University of Maryland in Medical Cannabis Science and Therapeutics, which makes me an expert in the field. I have been in and around the cannabis industry for the last 10 years. I have trained and opened multiple dispensaries, so I'm very well versed in the world of cannabis, and I don't believe in gatekeeping, so that's why it's free, right? So we're going to learn about the endocannabinoid system today. It's the most important system in the human body, and they never taught you about it in school. Isn't that a shame? Doesn't that suck? But, we're going to learn about it now. It's actually, the reason why your doctors don't know about it is it's in less than 3% of all medical textbooks. So your doctor is not even learning about it in med school. So we're going to learn about it today, though. But before we get started, I want to shout out to our sponsors. Our first sponsor today is Finzer's Finest, creating products we can use, so you can use them too. They are here. They've got a little table set up at the back. Ryan Finzer from Finger's Finest is here to talk to you about whatever you need. They are committed to quality cannabis products that meet the needs, really good needs of customers from, whether it's you just need to relax or you have some medical issues that need attention. They've got a lot of great RSO products and cured resin luster pods that will just do you real good. So check them out, fingersfinest.com. And we always want to shout out the Columbus Botanical Depot. They provide the space we're sitting in today. We have an array of companies, including, make sure you told them we're over here. Maybe they'll slide you a discount. Depends on who's working that day. Because if it's a newbie, they won't know about the discount. That's why I put that caveat on here. All right. So let's get started. So I'd say just assume that everyone in this room knows what happens when you consume cannabis, right? Like, stuff happens. Why it happens? Kind of. Yeah, exactly. What happens is the endocannabinoid system. So researchers have long suspected that there was receptors in our body because cannabis has an effect when you smoke it or eat it. It makes you feel different, right? It might take away your pain, might make you feel high, it might make your headache go away, it might make you nauseous. Whatever it is that it's doing to you, that effect is caused by cannabis because something in your body responds to it. And so the researchers and scientists are like, there's got to be a receptor that the molecules in this plant is binding to for it to work. And so in the mid-1980s, so not very long ago, Dr. Alan Howlett and her student, William Devane, at St. Louis University at Missouri, they found the first conclusive evidence of a cannabinoid receptor. So they're the first one to find the evidence that it existed. It's been around long before they found it, but they found it in the mid-80s. And then from the 1990s and onwards, they have started discovering, breaking down, and writing about the endocannabinoid system. So, pretty cool. But like I said, it existed long before the 80s when they discovered it, right? How long? Super long ago. So, over 1 billion years ago, life on Earth produced fatty acids that eventually led to the creation of endocannabinoids, which are cannabinoids that are made inside your body. What is a cannabinoid? It is a chemical component in the plant that causes effect on your body, whether it's THC, CBD, those are cannabinoids. And you have cannabinoids that your body naturally produces, like anandamide and 2-HE. So over 1 billion years ago, our endocannabinoids were forming on life on Earth. And around 590 million years ago, the first receptor appeared. And this guy, this is an ancient sea squirt. And he had the first receptor that we have found, the oldest living thing we could find, right? And so that means that after 500 million years, all vertebrates were born with endocannabinoids, cannabinoid receptors, and enzymes. And all of those together form the endocannabinoid system. People are not 590 million years old. That means the endocannabinoid system, the receptors, the endocannabinoids, the enzymes are older than human beings. So that started when life itself practically started on this planet, before the dinosaurs. So let's dive a little deeper into what all those things were: endocannabinoids, receptors, enzymes. So the main parts of the endocannabinoid systems are just that. So you got the cannabinoids, the enzymes, and the receptors. The endogenous cannabinoids are your anandamide, 2-HE. Your body makes them naturally. They're released naturally in the body. You can find it in breast milk, Most people, though, are familiar with exogenous cannabinoids, or cannabinoids found outside the body, like THC or CBD. And then your receptors are the sites in the body that those molecules bind to. And the enzymes are biological catalysts. Okay, so if you've ever sucked on a saltine cracker, you didn't chew it, you just sucked on it, and it just started breaking down in your mouth. That's because the enzymes in your saliva has the ability to break down starch. So there are enzymes in your body that have the ability to either build up or break down cannabinoids. So they play a big part on how well you metabolize the cannabinoids. It's one thing to put it in the receptor, that's fine, okay, we got it on the receptor, but can your body process it? Not without the enzymes. So they're super, super important. Huge, crucial roles in digestion, metabolism, DNA replication, detoxification, and tons of other functions. But they got a huge role in the endocannabinoid system as well. So cannabinoids. Again, you've got them in your body. They're natural. They're called endogenous cannabinoids or endocannabinoids. They're known as both. And their body's natural cannabis-like chemicals. The two main ones are anandamide and 2-AG. There are other ones that have been discovered, but they're not well researched right now. There's not a lot of literature about them. So we're going to stick with 2-AG and anandamide. But they affect mood, pain, brain development, and if they don't work properly, they can contribute to mental health issues. So your natural cannabinoids that your body makes can play a huge role in your quality of life. 2-AG strongly activates both CB1 and CB2. So you have two receptors, the two big receptors everybody knows, CB1 and CB2. So 2-AG will activate both of those receptors. Anandamide will activate both, but CB1 is weak. So, and in some cases, it can block stronger signals from other chemicals. So it depends on what it's doing and where it is, on how effective it is. But there are others. There's more than 4 even, but they're not very well researched. So you'll always hear 2-AG and anandamide. The anandamide comes from the Sanskrit ananda, which means bliss, the bliss molecule. It's linked to your oxytocin, the love molecule that makes you happy. So it's known as the bliss molecule, and it's pretty cool. And one of the only things that mimics anandamide is THC. So there are exogenous cannabinoids, which will be exhaustively went over in our next lecture next month. We're doing cannabinoids and terpenes, so you get to learn a ton about that. But we're just going to let you know that exogenous cannabinoids exist outside the body. They are found in abundance in the cannabis plant, but they do exist in other plants. They are called cannabinoids because they were found in cannabis. Cannabinoids found in plants are specifically known as phytocannabinoids. So you got your major cannabinoids, you got the THC, CBD, everybody's heard of those. The new big ones on the market are CBG, CBN. There's over 40 minor cannabinoids that could be on this list. But these are the big ones that you would see on a label of cannabinoids outside the body. And they connect to your receptors. What are your receptors? Well, we don't want to get too technical in here. It'd be a long day and it'd be really boring. But the receptors are basically a lock in your body, and you got to have the right key to fit in that hole to unlock it. So the two big ones are CB1 and CB2. They're the most studied, longest known. But there are other non-CB1, non-CB2 receptors, like GPR5. So here's a nice little illustration. It's not what your receptor actually looks like, of course. But let's say this is your CB1 receptor, and A is THC. THC fits in there, but maybe CBG doesn't, right? And it's going to activate, it's going to unlock that receptor, and it's going to get juices flowing. So let's talk about the receptors themselves. So CB1 receptors are heavily found in the brain. They're mainly found in the CNS, the central nervous system, so your brain and spinal cord. And the CB1 receptor is like a switch that makes you feel different when THC activates it. So when THC's key fits in its hole, it makes you feel different. It has an effect. It can change your memory, your mood, your hunger, and how you perceive pain. And scientists used to think that CB1 was only in the brain, but now we know it's everywhere, but it's mainly up here. It's mainly in the brain and spinal cord, but it does exist across the body. But when it turns on, it slows down brain messages between nerve cells, so it affects how you think, how you feel, how you move, or whether or not you get nervous. So think about how many times, maybe you're ADHD, and you smoke a joint and you're able to like focus. Yep, it's slowing down your thoughts. That makes sense. Or how many times have you had a crappy day and then you smoked a bowl and all was well? Yep, it's going to affect your mood. And how many people need to smoke weed before they go out in public because they're anxious? I mean, so many people. It works, and it's working on your CB1 receptors in your brain. THC loves the CB1 receptors. But research shows that CB1 helps control learning, swelling, and even body temperature. So think about that. When people tell you you smoke weed in high school, you'll be stupid, that's not necessarily true. It can affect how you learn. If you're ADHD, and it slows down your thoughts and allows you to focus, so your learning improves, doesn't it? So it's not a one-size-fits-all for everybody. You can't just give that message out and say it's going to make everybody stupid. No, it might make one or two people stupid, but they were going to be stupid anyway. That's fine. So, and then outside the brain, CB1 helps your stomach digest food by controlling how fast it moves through your guts. Peristalsis is important in your digestive system, how it moves from your stomach through your intestines and eventually out. If it's going through your intestines too quickly, you're not absorbing all the nutrients, you're not absorbing all the water, you can become dehydrated, malnourished, you can lead all kinds of problems. So CB1 can help regulate those receptors in your digestive system, help regulate how your food moves through your digestive system, and help slow it down if it's moving too fast, and it helps speed it up if it's moving too slow. There's been a lot of people with digestive issues that have touted the wonders of edibles and tinctures specifically, from everything from ulcerative colitis to Crohn's disease, et cetera, because these receptors exist in their digestive system. And there's CB2. He's cool. Mainly found in the PNS, the peripheral nervous system, and the immune system. So this is all the things that shoot out from the spine and the brain, your arms, your legs, your abdomen. So all the nerves that branch out. And researchers discovered higher levels of CB2 receptors in the brains of Alzheimer's patients, particularly in immune cells near damaged areas. And similar CB2 increases were seen in animal models of Huntington's, HIV-related brain inflammation, and multiple sclerosis, which suggests that these receptors are involved in neuroinflammation across brain diseases. So you've got the CB1 up there in the brain, mainly in the brain, but the one that's going to modulate the immune response and help with neuroinflammation in the brain is going to be CB2. And the reason why any of this matters is because some cannabinoids bond to CB1 better than they bond to CB2 and vice versa. So, I mean, it's beyond just looking up what cannabinoid is going to do what for you and just getting that. It's really honing what part of my body is affected, what receptors are there, what works on those receptors, what blocks those receptors, and you can really get nerdy in your medication with cannabis. So it's really, really interesting how these all work, and it affects so many parts of our body. One of the new girls in town is GPR 55. She's been around, but we're just starting to learn about her. And she's, you know, a protein receptor. She's found in pain-sensing nerve cells, and she activates and exposes the THC, and she increases calcium levels inside. So it signals G proteins and other pathways from CB1 and CB2. And that's kind of the main receptor when you're using cannabinoids or cannabis for pain, especially topically. This receptor plays a big role in its effectiveness because it modulates pain. So it's unique though because it also works alongside CB1, CB2. It's influenced by CB1, CB2. They kind of influence each other. It's kind of a synergy they have. And CBD loves this girl. GPR 55 is CBD's best friend. And we all know we use CBD for pain. This is why. Because it's over here antagonizing GPR 55 and getting it to increase calcium. It's doing this whole cycle here. And it's making sure that your body is getting the right signals to release the right chemicals to attack that pain. And then there's also what I call TERP channels, TRP channels. I call them TERP channels because of terpenes, but that's probably not the right way to say it. The transient receptor potential channel is basically a gate that lets things in and out, as long as you knock the right way. If you got the secret password, if you got the right key, it's going to let you in or it's going to let you out. And it's found in the membranes of cells. What cells? All cells. So you got the receptors, CB1 in the brain, in the spinal cord. You got CB2 in your peripheral nervous system, in your immune system. But then you got these guys. These guys aren't even cannabis specific. These guys work with so many chemicals in your body, not just cannabis. So they're in the membrane of almost every cell in your body. So if you want to know why you absorb cannabis so well, it's because your whole body has been primed to do so since before humans existed. So, and this one helps our bodies sense and respond to the environment. So temperature, pain, taste, plays roles in diseases like kidney disorders, chronic pain, nerve conditions. And studying them is helping scientists understand how our cells work and how to develop better medicines. So this guy might be a lot more famous in 20 years. We might learn something about this guy that's groundbreaking. Who knows? But they're looking into this guy to see if they can make better medicine for all of us. I think that's great. So you got her, you got GPR 55, CB2, CB1. Those are your receptors. There are more receptors that respond to cannabinoids and terpenes and flavonoids. But these are the four biggies that scientists have talked about and written about, have enough research to show they know what they're saying, right? They can back it up. But again, we're going to keep trying to explain how receptors work. So this is like a neuron right here. It's hanging out. It's not doing nothing. It's got some receptors on it, these holes here. And then you got some cells here. And some will fit these holes and some won't fit these holes. So receptors are like locks. Only specific keys like hormones, cannabinoids, etc., or drugs, aspirin, who knows, can unlock it. And when the right key binds the receptor, it triggers a response. The signal molecule fits into the receptor like a key in a lock. I keep repeating that because it's the easiest way to remember how receptors work. So anandamide binds to the cannabinoid receptors, and so does THC. So both the cannabinoids in your body and outside your body can bind to these receptors. This is a more scientific view. These are two neurons talking to each other. So neurons got little fingers at the end of them, and their fingers, they don't touch, but they talk to each other. And they talk to each other by sending chemicals back and forth. One from the top, one from the bottom, and vice versa. and they have receptors in them, right? And so this guy's going to send a chemical up, it's going to find its receptor, and this guy's going to send a chemical down, and it'll find its receptor. Sometimes the chemicals just hang out in the middle, waiting to find a space that they fit. And if they don't, they go back up. But this is a more scientific, neurons talking to each other. One says, hey, guess what I'm on? CBD. He goes, oh, no way. And so then the other one goes, okay, send me the CBD. He goes, phew. Because I've got the enzyme that's going to catalyze the CBD. We're going to metabolize it, and we're going to send that through. And it's going to activate all these channels that are going to send messages to release endorphins, oxytocin, whatever you need at the time. Insulin, whatever you need. Because the number one thing cannabis or your endocannabinoid system does is homeostasis. So that means keeping everything equal and even. Everything's good. Not too much of something, not too little of something. So if you got too much sugar in your system, it'll bring your sugar levels down. If you don't have enough, it'll bring it up. High blood pressure, it can lower it. Low blood pressure, it can raise it. It's all dose dependent. So it's not just some magical, I can smoke a joint and all my ailments will be cured. It does matter what you are consuming, how you consume it. But the main role for your ECS, your endocannabinoid system in cannabis, is to provide homeostasis. So what happens when you consume cannabis? We know all the parts, but what's happening? So what is happening? Cannabinoids, flavonoids, and terpenes interact with the body by binding to receptors, which are proteins, on or inside cells that normally respond to natural chemicals. Depending on how they bind, cannabinoids, flavonoids, and terpenes can either activate or block these receptors, leading to different effects. There's a really horrible picture down here, but if you can see it, it's either a ball getting through or a ball being blocked by another molecule. So you have a ball getting through, that's your agonist, it's getting in, it's being processed. You got an antagonist over here blocking the agonist from getting in, they're fighting for the same receptor. And over here you have the antagonist winning all day long, just like me. But that's how it works. So your agonist binds to the receptor, activates it, it mimics the natural chemical. So morphine activates opioid receptors to relieve pain. So it's an agonist on its receptor, on the opioid receptor. Antagonist is a drug that binds to a receptor but blocks it. So we all know by now, Narcan. You know, somebody's ODing on opioids, you give them Narcan. Narcan works by blocking the opioid receptors from taking in any more opiates. You can't. They're going to wake up sober and angry. They're going to feel like crap. But maybe they'll be happy they're alive. And then there's a partial agonist, which activates the receptor weakly, but also blocks stronger agonists. So it can either give it a weak effect, or it can block other things from bothering it. It's the easier way to say it. But we still got to talk about enzymes. Enzymes do a couple things. They degrade and they synthesize. We're going to talk about degradation first. So when an enzyme degrades something, it breaks into smaller parts, like that saltine cracker in your mouth. When you hold it in there, it just breaks down from the enzymes in your mouth. So it can be harmful to an unwanted substance. Are you hearing that? Yeah. Or unwanted substances like toxins, or it can break something down to be used so the body can absorb it better, right? And the key point is degradation. Degradation isn't just destruction, it's a controlled process, a meaning. It's not always destroying. Sometimes it's helping a molecule. Is this working?
Yeah.
Sometimes it's helping a molecule be absorbed by the body by being broken down into smaller pieces, which makes sense. I mean, if you're trying to dissolve something in water, the smaller pieces, the easier it is to dissolve. So if you think about it that way, degradation isn't always bad. And then there's enzyme biosynthesis, which is how your body builds essential molecules for growth, repair, and energy. So they make these reactions possible at body temperature, but without them, the process would be too slow. So enzymes can create reactions possible at body temperature that without them, the process would be too slow or impossible. Not enough to do everything it needs to do. So enzymes have to come in and create the chemical reaction. So enzymes act as builders, assembling small molecules into complex ones. Like they take amino acids and turn them into DNA. And this is the opposite of degradation. So not breaking things apart, but putting things together. And it often requires energy, lots of it. And each enzyme is specialized. So DNA polymerase builds DNA and fatty acid sleep base makes fats. So they all have their purpose. So they're either breaking it down or building it up in the system. So if you look at these squiggly things, I find them so entertaining. This is how these enzymes, if that's actually what it looks like under a microscope, or it's just the best way they can provide a visual representation. But these are the enzymes that are the major players in your endocannabinoid system. So shortly after 1995, we figured out that there were enzymes that create or break down the body's natural cannabinoids. So we knew there was natural cannabinoids, but we didn't know where they came from or how they metabolized. So in 95, we're like, oh snap, there's enzymes. And those enzymes are what's creating the cannabinoids or breaking them down, allowing us to absorb them. And so the main ones here are fatty acid amide hydrolase, FAAH, which breaks down anandamide. She was discovered in 1993. She's right here. Isn't she pretty? And then you got monoglyceride lipase, which breaks down 2-AG, your other endocannabinoid system. That was found in 2002, and she's right here. A little smaller, still cute. And then we got diacylglycerol lipase, which produces 2-AG, which is right here. She makes it, she breaks it down. And then you got NAPE PLD, which produces anandamide, which is right here. We say NAPE because so just NAPE. She makes anandamide. It's 2-AG. She breaks down 2-AG. She breaks down anandamide. So they come in to the receptors, they meet the molecules, and they do their job. But speaking of enzymes, enzymes are why edibles work the way they do. So when you smoke cannabis, it goes through your mouth, into your lungs, and back out. It is absorbed through the capillaries in your lungs, the molecules. That's how it gets into your body, straight to the bloodstream. When you eat edibles, though, it has to go through your digestive system. That's why it takes a while for it to kick in, right? So it goes through your digestive system, and it gets metabolized in the liver by two enzymes, CYP2C9 and CYP3A4. Now, this is where it gets interesting. So some people know, maybe not everybody in this room, know that smoking cannabis and eating cannabis are two different experiences, right? Eating cannabis is known to feel a lot stronger and last a lot longer, right? Well, why is that? Well, it's because it's being metabolized in the liver. THC is rapidly oxidized to its active metabolite, 11-hydroxy-THC, and it further breaks down to THC, COOH. What does that mean, right? So these enzymes here, CYP2C9 and CYP3A4, to its active metabolite, the thing that actually makes you feel high, very quickly. And then it further breaks it down to THC, COOH. This process, this 11-hydroxy OH-THC, is stronger than delta-9 THC. This THC, COOH is stronger than delta-9 THC. So it is being metabolized into a stronger form in the liver. And the effects of these metabolites can be felt for a longer duration than inhaled THC. Fun fact, my 23andMe tells me I don't really create CYP2C9. Now, they were telling me that for a totally different reason. They're not looking at your endocannabinoid system on 23andMe. But I find that interesting because me and edibles, I don't get the hype. I don't get to experience it the way everybody gets to experience it. I'm going to have to take hundreds of milligrams to get an effect, and that effect will last 30 minutes if I'm lucky. I will say, through my years and years around cannabis in the industry, and all the years I've worked at a dispensary, the number one type of person that tells me edibles don't have an effect on them is somebody who has some kind of red hair. Gingers. Whether it's a copper beard. Sometimes they got dark black hair on top, but they got a copper beard. They will also suffer. So this is an enzyme that has to do with drug metabolism. It's beyond just cannabis metabolism. And so there's a thing with redheads where they need more painkillers than the average bear because it's not going to have any effect on them. They need more anesthesia because it's not going to have an effect on them. And we process drugs rapidly, which means ibuprofen says take every 4 to 6 hours. I'm going to need it every 2 to 4 hours because it's in and out my body. So when I'm coming, my own conclusion, I'm not saying this is true, is it's probably got to do something with that enzyme right there. It says I barely got it, I'm not producing it, and that's why my edible experience is nil, because it's not getting metabolized into 11-hydroxy THC. I'm just eating money, basically. So it's a love-hate relationship. I really want to love edibles, but I hate spending money on it. But that's why it's those enzymes in your endocannabinoid system. So I got some fun facts for you. Now that we know about all the little parts, all the little things that are happening in your endocannabinoid system, let's share some fun stuff. First fact, you would not be here without your mom's endocannabinoid system. Fact number 1. Remember anandamide, or bliss molecule, the one our body makes all by itself, and it's in breast milk? It determines whether or not an egg will attach to the uterine wall. So when an egg meets a sperm and gets fertilized, it has 2 options. They can attach to the uterus and grow and become a fetus and eventually be born into a baby. Or they can just leave the body and never come to fruition. The anandamide in your body, in your mother's body, controlled whether or not you were ever going to exist. So your endocannabinoid system is responsible for life itself. Isn't that pretty cool? It's super, super, super technical, but they show that depending on levels of anandamide and the activity of the enzyme, will determine how well a woman can keep a pregnancy to term or not, basically. It's really interesting. Another fun fact, schizophrenia. I love this one. So many anti-cannabis people out there will talk to you about your risk of schizophrenia if you smoke weed, right? I don't know if has anybody heard this? I know I have. I minored at OSU in substance abuse. That's a real minor. And it was taught to us pretty heavily. The study that comes from is you got to be 15 years or younger, male, and genetically pre-exposed to schizophrenia. And schizophrenia can be triggered by drinking a beer, smoking a cigarette, getting in a car crash. They also forget to tell you that when they tell you that you are risking schizophrenia with cannabis use. Now, anything you do before your brain is fully formed can have a negative effect on your brain. That's just it. Period. Caffeine can. So I'm not saying like cannabis is like never bad, when you're a minor, but it's not the end all be all. So scientists, though, think that the CB2 receptor might be linked to schizophrenia. That one that's also linked to Alzheimer's, Huntington's, all those brain diseases. So people with a lower CB2 activity or certain genetic changes in the CNR2 gene, which makes the receptor, may have a higher risk of developing schizophrenia. As many CB2 receptors in my body, I'm at a higher risk for developing schizophrenia or schizophrenic-related symptoms. So in mice, they found blocking CB2 made schizophrenia-like symptoms worse. They blocked it. And so they were being overly startled by sounds. But when they activated it with certain drugs, it reversed the symptoms, which suggests CB2 can help treat schizophrenia. CB2 receptors are found in brain areas linked to schizophrenia, like those controlling dopamine. That's your reward chemical. That's how you get addicted to things. Gambling, sex, drugs, all that is activating your dopamine. So it controls dopamine and memory. And activating CB2 might help calm down an overactive brain and the signals in schizophrenia, making CB2 targeting drugs a possible new treatment. So we have one side of the world telling us cannabis is going to cause your schizophrenia, and you have the other side of the world saying, we could treat your schizophrenia. I do have an anecdotal story about that. I had a therapist years ago who was a bit unconventional. Because when I started teaching her about cannabis, basically, in my spare time after my session, she'd have all these questions because she's trying to help her other patients. And so I would give her what I knew at the time. And she started giving, and she told me about it, which is why she's unethical. Don't listen to her. But she started giving CBD pills to a schizophrenic patient who was already on like regular prescriptions for schizophrenia. And I guess what it was is he's on these pills and he heard voices and he saw things, and the pills kind of quieted it down, but it was still there. So she gave him CBD pills, and he said it went away. No more hallucinations, no more visual hallucinations. With a regular steady diet of CBD, he was fine. And I was still dealing with her for at least 6 months after she started telling me about him. In that whole 6 months, he was thriving. Adding CBD, he didn't take away anything. He was still taking his prescription medicine. But adding the CBD in, which is the only thing he changed, took away all the rest of his hallucinations that the prescription pill couldn't touch. So that story has always stayed with me. I appreciate her sharing that with me. It was really nice of her to do so. She should have never have talked about any other patients with me. Ever. But I'm glad that she did, because it gave me that story and allowed me to continue with my own curiosity in the science behind cannabis. So she played a part. Everything happens for a reason. And then we're going to talk about autism spectrum disorder. This one's interesting. Ohio keeps denying it every year when it's up to be added to the medical program. And they have to present new research every year. And they still say, no, no, no. Scientists discovered how the endocannabinoid called anandamide works with oxytocin, which plays a big role in social behavior. So your social life is also controlled by your love chemical, oxytocin. So it affects how we enjoy social interactions. Oxytocin is also linked to autism spectrum disorder, where people often struggle with social connections and rewards. So anandamide binds to the CD1 receptors, the same target affected by THC. Affected by THC. That same target, anandamide, binds to CD1 just like THC, and it influences behavior in similar ways. So several studies have found that cannabis treatments help reduce various symptoms such as hyperactivity, self-harm, anger outbursts, trouble sleeping, anxiety, restlessness, irritability, aggression, and depression. And some people also saw benefits in thinking skills, focus, sensitivity to stimuli, social skills, and communication. The side effects they found were sleep problems, restlessness, nervousness, and changes in appetite, which I'm willing to bet they just need different terpenes. This is interesting. So people born with autism spectrum disorder have a natural deficit of anandamide, which means their body doesn't make as much as it's supposed to. And the only thing we have discovered thus far in 2025 that can mimic anandamide in the body is THC. There are hundreds, if not hundreds of thousands, of anecdotal stories out there of neurodiverse people from ADHD to autism spectrum disorder that say, I use cannabis every day because it makes me feel normal. I can be a human. I can function. I can laugh. I can eat. I can be around people, right? And I find this very interesting as somebody who just last year was diagnosed with autism spectrum disorder in her late 30s. This hit me like a ton of bricks, this research, because I have said since the beginning, and the world has told me, no, you're just an addict. But I have said since the beginning, I'm a real person with cannabis. Without it, I can't handle the world. It's too big, it's too loud, it's too smelly, it's too noisy. I mean, the hum of every electric thing in this room, the light, everything coming in is so distracting. It's so hard to just be a person and be a nice person. That's the thing. I can live my life without cannabis, but everyone around me will be freaking miserable. Because my ability to stay calm with all of those things coming at me is so small when cannabis isn't there. And I will snap at you for nothing. Just look at me wrong. And I'm like, ah! Why is everything like this? Why can't everybody just behave the way I want them to behave? Because my way is the right way. And that's autism for you in a nutshell. So yeah, it is very possible that the reason so many autistic individuals and ADHD individuals reach for cannabis is because it actually is helping us. Sure, yeah, we get high. We have fun, we have the giggles. Absolutely. I will definitely double down on my medication if I'm about to watch some stand-up comedy. I'm getting stoned. Definitely. But to get through any day, just being a person, being able to take the sunlight coming in my house, the smell of the litter box, and the smell of my son's deodorant on top of the smell of the soap in the bathroom, and the hum of the fan in the bathroom on top of ticking of the clock and all that sensory input that would otherwise make me have a panic attack or make me lash out at loved ones is totally, I can totally deal with it if I've got, it's fine. It's totally fine. You know I need to medicate if I'm starting to get a little itchy. Like, what was that? Like, ooh, my bad. What'd you say? So the aggression, anxiety, irritability, all those things I deal with, just waking up and being alive, is manageable with cannabis. Without it, I just want to kill the entire world. Just kill them all. Start over. Screw this place. Get me off this planet. You know? But with cannabis, I'm like, no, it's not so bad. Look at the sky. It's blue. It's pretty. Look at the clouds. So that one's really important to me. But the thing is, we just touched on something that somebody has theorized. Clinical endocannabinoid deficiency syndrome. So autistic individuals are born with less anandamide than they should. They're deficient in anandamide, right? Well, what if autism is caused by clinical endocannabinoid deficiency syndrome? So there's this scientist named Dr. Ethan Russo. He is the man in cannabis science. And he proposes that certain chronic illnesses like migraines, fibromyalgia, irritable bowel syndrome might be caused by a lack of endocannabinoids in the body, whether you're not storing them well or you're not producing them well. And this idea is called clinical endocannabinoid deficiency. And he dropped this in the early 20-teens on all the research pages. And he's since gone back to it, went back to his research, and reconfirmed his original findings. So we know that autistic people, they got a deficiency. What if fibromyalgia is a deficiency? What if irritable bowel syndrome is just a deficiency, 2AG or something? What if we knew that and we could just flip that switch and get rid of these things with a pill or something, or just smoke weed? Who knows? You know, not everything has to be pharmaceutical, but this is usually how it ends up. So let's think about this: endocannabinoid deficiency syndrome. Well, what could cause that? If the endocannabinoid system is older than human beings, you're talking at least 590 million years old. What would make it go wrong? Why isn't it there? Well, there's a lot of things, but one of the things is we're not supplementing our diet with cannabinoids anymore. So man has used some form of cannabis for thousands and thousands and thousands of years. Medicinally, spiritually, recreationally, topically. They've ingested, they've smoked it, they've hotboxed it. You name it, they've done it all. And a lot of farmers also, on top of man using cannabis, even if you weren't using cannabis, you were probably ingesting it through the food you ate. Because a lot of farmers used to throw their hemp scraps into their feed for their cattle. Now, there once was a time in this country when there was over 8,000 hemp farms that were at least 20 acres. That's a lot of farmers and a lot of hemp scrap going into cattle, right? There is a positive correlation between the prohibition of cannabis in 1937 to the rise of metabolic disease, heart disease, stroke, cancer. If you look now, correlation does not equal causation. That's the number one rule of science. Just because they're related doesn't mean they're causing one or the other. You got to look further into it. There could be a third thing, a third factor causing these results. But if you look at metabolic disease and the timeline of when prohibition started, when we took cannabis out of the food chain. So maybe taking cannabis out of our food chain caused more damage than we realize. Maybe you're not just what you eat, but what your food eats. maybe that's contributing to our clinical endocannabinoid deficiency syndrome. Maybe that's contributing to our increase in mental health issues and autism spectrum disorder and ADHD. Perhaps man survived for so long with exogenous cannabinoids found through the food chain and through their recreational activities or spiritual activities. That this is all happening now because when America got rid of cannabis, the world got rid of cannabis. It wasn't just us. So it's a hypothesis that a lot of us activists out there, we postulate about, we sit and talk about, we took it out of the food chain and all this stuff is happening. I bet you there's something to it. Okay. So that was exhausting, right? A lot of information. But do you want to test your knowledge? You want to test it? We're just going to sit here and test it. It's not going to be a grade. Anything. You can holler the answer if you know it. Say it. Okay, this is just for fun. We're going to test your knowledge. Are you ready? Okay, trivia time. Oh, yeah. Trivia. So in the mid-1980s, Dr. Alan Hallett and her student William Devane at St. Louis University, Missouri, provided the first conclusive evidence of what kind of receptor? Exactly, a cannabinoid receptor from your endocannabinoid system. All right, who's next? Question 2. How many million years ago did the first cannabinoid receptor appear? 590. Hey, you guys, the back of the room is showing you up. Isn't it supposed to be the front of the room that knows all this stuff? Yeah.
That was the misnomer.
Exactly.
Don't get tongue in bed.
Yeah, love it. All right, about 590 million years ago, receptors mainly located. You got it. In the brain and spinal cord, known as the CNS, the central nervous system. Yeah, that's for your anatomy nerves, the central nervous system. Who needs to know that? It's brain and spine. Question 4, where are CB2 receptors mainly located? So the other ones, where are they? They're in your nervous system. What kind of nervous system? Peripheral. So it's branching out in the arms, the legs, the abdomen, coming off the spine. It's also known as the PNS, which is a lot of fun to say because everybody thinks you say peanut. It's the PNS.
Yes.
Yeah, I'm a pianist. That's fine. Question 5. What type of cannabinoid is found inside the body? Endocannabinoid. That's right. Endo is inside. Exo is outside. Very good. You guys killing it back there. Oh, gosh. Question 6. What do you call a cannabinoid found in plants? Phytocannabinoids. All right. He's finally doing something. Phytocannabinoids. You also could have said exogenous cannabinoids. That would have been okay. Cannabinoids and terpenes bind to receptors. That's right. They bind to receptors. CB1, CB2, GPR55. What are the 2 most studied cannabinoid receptors? Yes, CB1 and CB2. I hate this microphone. CB1 and CB2. Good job. What are the 2 most studied endocannabinoids? That's an exocannabinoid. Talking about the body. That's okay. 2-AG and anandamide. Yeah, the bliss molecule and 2-AG. We call it 2-AG because their name's too long and complicated. Question 10. Which endocannabinoid plays a role in reproduction? Bingo! Anandamide. Looks like the front of the room is catching up. It's the difference between who paid attention in the beginning and who paid attention in the end. Right?
Depends on when the medication started.
Right? When did the edible kick in? All right, question 11. When you eat a cannabis edible, what organ in the body metabolizes the THC?
Liver?
Liver. Remember, it metabolizes it with those enzymes, turns it into 11-hydroxy-THC, which is why it's longer and stronger. All right, last one, you guys. What creates or breaks down the body's natural cannabinoids?
Yeah.
No, it's part of the ECS. Enzymes. Yes. Enzymes. It's a tie. Everybody wins here today. You're here today, you win. Period. Enzymes are great. Okay. So you guys are awesome. You paid attention. You absorbed it. I hope it wasn't too heavy. The endocannabinoid system is a hard thing to explain without getting way too scientific on people. So, but we do have upcoming events. August 1st, there's a grand opening party for True Leaf Columbia Tuscaloosa. At Stanley's Pub, which is in Cincinnati. It's from 5 to 9. It's going to be a great time. I highly recommend coming. Cincinnati is not that far away, guys. It's like an hour and a half. It's fine. And then next month in this same space, we're offering another course, Budtending 104, cannabinoids and terpenes. So you get to learn. We're done with the endogenous ones. You get to learn about the exogenous, the phytocannabinoids. We're going to learn about THC, CBD, how it binds, what it does, and terpenes, and how they work together, and entourage effect, and all that good stuff. And that'll be here, same times, unless otherwise noted.
That'll be sponsored by Bloom.
That'll be sponsored by Bloom.
And
yes.
you can get your medical cannabis card in Ohio, either a new or renewal.
Yes, and you can get your card
for
renewed,
free here.
or get a new one for free during this event. So you want to come on down. You got to be here to get it. So if you know anybody who needs their card or needs to renew, bring them down here. August 16th. And then they can learn about cannabinoids and terpenes and seem like a genius when they go to the dispensary. Yeah. But we are so thankful for your participation. We are so thankful for our sponsor, both of our sponsors, Finzer's Finance, CBD Depot, right? We appreciate your participation. If you want a certificate that says, hey, I learned something today, it'll be sent to your email. If you fill out, there's a clipboard at the front of the room here. Put your name, your email, and I will email you a digital certificate. Are there any questions, concerns, suggestions? All right. Well, I appreciate your participation. You're welcome to hang out.
Thank you.
Network whoever's here. You can leave. You can do a little jig. Thank you for being here.